we've talked about unit rate in previous videos, and now we are setting up rates as well. This is using ratios, which remember are basically fractions. They're comparing things while fractions are looking at parts out of a whole. So we've talked about when we have word problems, how we create fractions or ratios from those. So we're just continuing to build on those skills. Note that it says the rate needs to be written as a fraction in lowest terms. Now, I always tell my students, unless otherwise noted, you always need to fully reduce fractions. So even if it didn't say that, we would go ahead and go through that process of simplifying. So for the first one, we have 150 gallons of water is added to a pool in 2 hours. How much water went into the pool after 1 hour? All right, so remember that I just do one read through and then I start pulling the important information out. So I have 150 gallons is added in 2 hours. The question is how much water went into the pool after 1 hour. I like to think of these as equivalent fractions. So this is calling way back earlier in the videos. And that's where we start with our given value, right, which is 150. And we want to include our units as we set these up because we have to include units at the end. So we have 150 gallons per 2 hours. Well, we only know part of our other fraction, and that's the amount of time, but we're trying to figure out how many hours. So if we do 1 hour, right, now we can look and see, well, using, again, it's multiplication or division. What do I divide by? Because the number I'm starting at goes smaller, right? I'm starting at 2, I'm going down to 1. So I have to use division, and whatever I do to the bottom, I have to do to the top. So I divide by 2, I divide by 2, and that gives me 75 gallons. Now, there's another way that we can do these, which probably feel a little more straightforward. And that is to use the fact that fractions and ratios are the same as division. So if you didn't want to set up the equivalent fraction like we did here, we could do 150 gallons divided by 2 hours, and then go ahead and just do that division. So you would do 150 divided by 2, and that gives you 75 gallons per hour, which notice is what we got before. Now, this works well if you are going to a unit rate, which means one of your units is 1, right? So we're trying to figure out the number of gallons in 1 hour. However, we aren't always asked for that unit rate. We're asked for something else. So the first way that I showed you is something that you can use all the time. I always tell my students that I like to teach what can be used all the time. And then as you become more comfortable, you have other things that you can shift to if you can understand, right? Like when it's appropriate to use something and when it's not. So the first way that I showed you works all the time. The second works whenever you're finding unit rate. So let's look at B. Go ahead and pause the video. You can try, I would encourage you to try both methods that I showed you in A. If you're less comfortable with one, I would do that and then do the method that you're more comfortable with to check how you're doing with that new way. These strategies are things that you need to learn for what's coming, and giving yourself a chance to practice them is really important. All right, so here we have Jake earns $160 in 8 hours. What is Jake's hourly rate? So hourly rate, we're looking for basically income per hour, per single hour. So this means we're looking for a unit rate. That means I can use that second method. Because we're looking for the unit rate, I can take that 160 over the 8 hours. I divide that, and I get $30 per hour. Or I could do that first way, which again will always work. And we have 160 divided by 8 hours equals, now think for a second, what is the new denominator that you're going towards? Well, we're going for 1 hour, right? So this looks like what we did in A. Now we divide top and bottom by 8. And again, we get 30. All right, go ahead and do it again with C. So we have the same setup here. We have Joel traveled 160 miles in 2.5 hours. How fast was he driving, rounded to the nearest mile per hour? Okay, so first I'm going to go pull out the important information. Then we're going to think about, in our real lives, how does this fit in? This is actually a measurement that if you drive a car, if you ride a bus, you encounter this daily. Okay, so it's really important whenever we can to link what we're talking about to something that we do every day, or very frequently at least. Okay, so we have Joel traveled 160 miles in 2.5 hours. So I care that he drove 160 miles in 2.5 hours. How fast was he driving? So we're looking for a rate rounded to the nearest mile per hour. All right, if you're not sure how to set this up, I want you to look at the units that we have. So when we're driving a car, right, we talk about we're driving, well, here in the US, we talk about that we're driving 60 miles per hour. Well, in the past, we've referenced per as being division. So I can use my units to show how to set up my problem. So if it's miles, right, that goes in the top. Per is my division line. Hour, or hours, that means that the miles that I've been given has to go on top because that's where my miles are. And then my 2.5 has to go in the bottom because that's where my hours are. Now notice I didn't think about it in terms of am I doing division, am I doing multiplication? I literally just took the layout of the units of my final answer, miles per hour, put them in place, and then put the numbers next to the appropriate unit. This is something that we're going to use a bunch when we're doing solving proportions and then also unit conversions. So starting this process, introducing you to this process now helps you here, but also helps you with what's coming. So now we can go ahead and do our division. And that gives me 64. And it says to round to the nearest mile per hour. Well, it's a whole number, so we're all good with that. And it's miles per hour. So 64 miles per hour is how fast Joel is driving. Now, using this same sort of setup and using proportions, we can compare values. Okay, we can also compare values by looking at unit rates. So that's what we're looking for here when we're talking about comparing values or cost or deals. So each of these, the $6.25 for 5 pounds, we want to figure out, well, with that amount, with that relationship, what does 1 pound cost? So that's another where we take our first value and notice it's money per pound, right? Or dollars per pound, which hopefully sounds familiar to you. So again, that is a way that we can use these units to help us set these up. Money has to be on the top, pounds have to be on the bottom. So I go ahead and divide. And I get that 1 pound costs 125 cents or $1.25, okay, per pound. Now I need to do that again for the $9.45 for 7 pounds because again, that gives me a comparable amount. I need to know for each of these how much 1 pound costs as a result. So unit rate. So 9.45 divided by 7, and we get $1.35 per pound. Then we need to do the last one, which is $4.80 for 4 pounds. So I go ahead and do that division, and I get $1.20 per pound. Well, looking at that, right, $1.20 per pound is the best deal. So it would be this one right here that you would want. So we're going to do the same thing in 3. So go ahead and pause the video and try this problem and then turn it back on and see how I take you through it. All right, so comparing, we have to remember when we have 2 units, we're going to be using a ratio because something is happening over something else, right? There's a relationship between the two. And then to be able to compare these things, we have to get the unit rate. So I have 150 miles. Now keep in mind, we have speed, right? Well, it's speed when you're driving on the freeway, which means our unit is miles per hour. So again, miles on the top, time on the bottom. And then I can just go ahead and divide that out. And so I get 75 miles per hour. Now we have 280 miles over 4 hours. Okay, so that's going to give me 70 miles per hour. And then we have to do the same thing here, 340 miles per 5 hours. I go ahead and divide that out, and I get 68 miles per hour. Okay, now we're looking for the fastest speed, right? So this one right here is fastest.